Welcome back to the deep dive. Wow. This week, we tackled a pretty huge stack of sources.
Yeah, it was
24 distinct news items, all from early November 2025, tracking AI advancements. And honestly, it felt less like just a busy week and more like a real shift in the industry structure.
a structural inflection point, definitely.
Okay, so let's try and unpack this. We've got everything from pure math breakthroughs to new enterprise hardware, big governance changes, even totally new ways of writing software.
It's a lot.
Right. So our mission here is to pull out the real signal from all that noise, give you the map of what actually mattered this week.
And what's really fascinating, I think, is you can clearly see this.
Yeah.
Industrialization phase picking up speed. AI isn't just the frontier models anymore.
No, it's moving beyond that.
It's becoming institutionalized. Infrastructure, actual governance rules, specialized apps that last.
So, yeah, to make sense of it all, we've grouped these 24 updates into 6 themes.
Makes sense. Where do we start?
Let's start with where the speed demands the most attention. Safety and the guardrails. Okay, safety first. Makes sense.
Yeah.
The speed AI is moving at. Well, it needs defenses that can keep up. And it feels like we saw a real shift towards dynamic auditable governance this week.
Precisely. Look at item 1, this launch of gpt-oss-safeguard. The clever part here isn't just a better filter, it's policy that sort of thinks out loud.
Thinks out loud. How so?
Well, the system classifies messages, but it does it with auditable reasoning. That means the team can literally just edit the policy text to change how it behaves.
Instead of having to retrain the whole model.
Exactly. You don't need weeks of retraining. You edit the text, the behavior changes, it decouples security policy from that really expensive training cycle. Iteration becomes almost instantaneous.
Okay, that's a big deal for speed. And that speed seems mirrored in item 2, the OpenAI Aardvark agent, this agentic security researcher.
Right. It treats security less like a one-off audit and more like a living immune system for the code. Aardvark actually watches the code, builds its own threat model, tests its findings in a safe sandbox environment, and then, get this, it proposes a specific pull request, like the actual code diff, to patch the vulnerability.
So it's not just flagging problems, it's suggesting fixes.
Yes, it shifts security from just pattern matching known issues to reasoning about the logic of potential flaws. But, that raises a pretty important question.
Which is?
If an agent proposes the patch, who's ultimately accountable? And that's why the governance piece we saw is so critical.
Right, let's connect that. Item 4, the Microsoft and OpenAI partnership reset. That seemed very focused on this kind of structural accountability.
Totally. They put 2 major guardrails in place. First, OpenAI's API stays exclusive to Azure before any AGI declaration happens.
Okay, that locks things down commercially.
And second, and this is maybe the bigger one, they added an independent expert panel to formally verify when or if that AGI threshold is actually met.
So it's not just the companies deciding internally anymore.
No. That verification step, that crucial judgment call about risk, is moved outside the companies to an independent body. That's a massive structural change in governance. Oh, and they also confirmed that Microsoft's old right of first refusal on compute is gone, simplifying things down the line. Okay, so moving from securing the models to actually using them. The tools developers use are being completely reshaped. It's all about speed and integrating agents directly into the workflow.
Yeah, this theme felt like it was all about removing friction, making things faster and smoother for developers. There was that quiet one, item 3, ChatGPT Atlas OWL decoupling Chromium.
Yeah, that's a subtle but really important pattern.
Yeah.
They're separating the core browser engine, the Chromium part, from the native app shell. They use things like Host for rendering.
Okay, but why should a busy developer care about that?
Because it means more stability, fewer crashes, faster upgrades, especially for apps that heavily use agents. It basically makes agents a reliable first-class part of the environment, not some add-on that might break things.
Got it. Reliability for agent-heavy apps. And this idea of frictionless development. It feels like Google's really leaning into that with vibe coding, item 6, in AI Studio.
Oh, absolutely. Vibe coding is all about momentum. You describe an app, maybe just roughly, and bam, you get a working scaffold to start with.
Just like that.
Pretty much. And the really cool part is the annotation mode. You can literally highlight a widget on the screen, a button, a form field, and just ask the AI to tweak it. Make this button blue, or add a password field here.
Wow, so you're visually editing with prompts. That must cut down the time from idea to working prototype drastically.
Exactly. And this whole new way of working, vibe coding, it's now being formally studied.
Hmm.
Item 9 was a survey, kind of a first field guide to this paradigm.
And what did the survey find? Is it just about bigger models?
Not really. It argued that the architecture around the model often matters more. Things like having really good retrieval systems, secure sandboxes for the code to run in, and clear structured specs for the AI to follow.
So the supporting infrastructure is key.
Right. The survey suggested failures in these systems often look like planning debt, like the setup wasn't right, rather than the AI model itself lacking capability.
Interesting. And that focus on tooling seems to connect to item 13, Cursor 2.0.
Yeah, Cursor 2.0 is pushing this hard. It ships with Composer, which is their own fast in-house coding model, plus a genuine multi-agent IDE.
Multi-agent, so multiple AIs working together.
Kind of. It starts from your high-level goals, not just you opening files. And yeah, these agents can run in parallel, but crucially, with isolation between them, they act almost like QA partners, helping check things. Super useful for big, complex code bases like monorepos.
Okay, so the IDE itself is becoming more active. And to cap this off, item 24, the Minimax M2 mini model. That sounded big, but also small.
Huh. Yeah, it's a bit of a paradox. It's a massive model overall, 230 billion parameters, built using a mixture of experts, or MOE approach.
The MOE, right, where only parts of the model activate.
Exactly. So even though it's huge, it only uses about 10 billion active parameters at any given time, specifically targeted for agentic coding tasks. Things like editing across multiple files, fixing tests automatically, even running shell commands.
And it performs well.
Extremely well on coding benchmarks like the SWE bench variants. So the insight here, I think, is that the IDE is shifting from just being a passive text editor to an active system that helps you achieve goals. The bottleneck is becoming defining the goal, not writing the code itself.
Okay, this next theme. This is where things get really interesting, I think. How the models actually think. We're seeing some fundamental breakthroughs in reasoning, in learning, and often without needing tons of that expensive labeled data.
Yeah, this is the deep science stuff. Let's start with foundational knowledge, item 5, the AI for Math initiative. This is a major coalition, Google DeepMind, Imperial College, the IAS.
The Institute for Advanced Study, right?
That's the one. Plus others. They're backing pure mathematical discovery using AI. Partners get access to powerful systems like Gemini DeepThink and AlphaProof. The goal is to turn individual math insights into a shared, durable pipeline for developing new theories. It's like building infrastructure for discovery itself, so progress compounds.
Building on previous work automatically.
Yeah.
And we're seeing cleverness in how models infer things too, right? Item 8, reasoning with sampling.
Yes, this was a neat one, a simpler approach that, kind of surprisingly, matched reinforcement learning, or RL, on some really complex reasoning tasks.
Simpler how?
Instead of doing complex, expensive training loops after the main training, it shifts the computational work to when the model is actually generating text. It basically resamples bits of the output, the token spans, to focus the model's attention on more logical or promising lines of reasoning.
Okay, so smarter generation, less post-training correction. That raises a question, though. Can these models actually report on their own internal processes? Item 18, Anthropic's report on LLM introspection.
That's the million-dollar question, isn't it? And Anthropic found early, tentative signs pointing towards yes. They discovered that models could sometimes detect an injected thought, like a specific concept researchers forced into its process before that thought actually appeared in the text the model generated.
Whoa, like a flicker of self-awareness.
Maybe functional awareness is a better term. It's a hint that the model has some access to its own internal state. And that's potentially huge for safety and debugging. Imagine asking a model, are you sure about that answer? Or are you about to generate something harmful? And it being able to give a meaningful response based on its internal state.
That would be transformative for trust and safety. And this theme of self-improvement seems to run through item 21 as well, multi-agent evolve.
Right. This used reinforcement learning again, but in a clever way. It co-evolved 3 distinct components, a proposer agent, a solver agent, and a judge agent, all starting from the same base model.
So they teach each other.
Essentially, yes. This structure helps organize the reasoning process without needing pre-labeled right answers. And it led to big performance gains compared to just standard fine-tuning on labeled data. It's a way to scaffold reasoning.
Very cool. And finally, item 23, DeepMind, using RL for creative chess puzzles.
Yeah. This showed RL's power in a different domain, They used RL, but the reward signal wasn't just winning the game. It was based on chess engine search statistics, kind of approximating human expertise and surprise.
So the goal was novelty.
Exactly. To generate puzzles that human players rated as more creative and enjoyable, they actually got a tenfold increase in a metric they called counterintuition. It really shows how RL can be used to synthesize not just correctness, but also qualities like creativity or surprise by defining the right reward. All right, theme 4. This is where the sheer scale of the AI build-out becomes undeniable. We're talking about AI as an industrial utility now, which means digging into the hardware, the power, the physical infrastructure.
Yeah, the nuts and bolts.
Exactly. Take item 10, Nemotron Nano VLFP8. This is an NVIDIA vision language model, a VLM specifically designed for enterprise use cases, like understanding complex documents.
What's special about it?
It uses low-precision FP8 math, which saves memory and compute, and a clever tiling scheme. This lets it handle really big, high-resolution documents, think engineering blueprints, legal contracts, without totally overwhelming the system's memory.
So it makes processing dense visual data more efficient.
Precisely. And importantly, it's designed to run well on existing hardware, like H100 GPUs, making it practical for enterprises to deploy now.
Okay, and speaking of NVIDIA, their GTC conference keynote, item 11, seemed laser-focused on this AI factories idea.
Oh, absolutely. The core message there was simple. Peak performance, maximum throughput, comes when you co-design everything. The chips, the networking, the software, even the physical infrastructure.
Oh, designing everything.
Yeah. They showcased the Grace Blackwell superchip platform connected with NVLink 72, which essentially turns a whole rack of GPUs into one giant interconnected processor. But maybe even more telling was the emphasis on Omniverse DSX.
What's that?
It's their platform for designing and simulating complex systems. They showed how it's being used to co-design the physical data center systems, like cooling and power delivery before you even pour the concrete.
Wow. So infrastructure planning isn't an afterthought anymore.
Not at all. It's fully integrated into the AI development lifecycle now. It's fundamentally changing how data centers are designed and built.
And speaking of data centers, item 22 highlighted the massive capex increases from the tech giants for AI capacity.
Tens of billions of dollars added to spending plans by Meta, Alphabet, Microsoft. It's staggering. And this capacity race isn't just about buying more GPUs.
Right. The report mentioned other crucial investments.
Yes, those budgets explicitly include huge sums for renewable energy projects, major substation upgrades to get more power to the data centers, and water reuse technologies for cooling. It makes it crystal clear. Reliable power and managing the environmental footprint are now the absolute gating factors for future AI growth. Silicon is almost the easy part now. Power is the bottleneck.
Okay, so we've got the safety, the dev tools, the core research, the factories. Now let's look at where this is all being applied. Theme 5. High-value vertical applications. These updates really show AI moving into specialized workflows where reliability and domain knowledge are critical.
Yeah, moving from the general to the specific, like item 7, Pomelli. This is a tool from Google Labs and DeepMind aimed at small and medium businesses.
What does it do?
It basically learns a company's specific brand DNA directly from their website, the tone of voice they use, their color palettes, their fonts.
Ah, so it gets the vibe.
Exactly. And then it ensures that all the marketing content the AI generates, social posts, email campaigns, whatever, is consistent and coherent with that brand identity. That's a massive help for lean teams who need reliable on-brand output without constant human checking.
I can see that being huge. And in a totally different field, life sciences, item 12 was the OpenFold 3 preview.
Right. OpenFold 3 is a foundational model for predicting protein structures and even how drugs might interact with them. And significantly, it was released under an Apache 2.0 open source license.
Open source. Why is that important here?
Because the goal is to create a trusted, shared base layer, kind of like Linux for operating systems that researchers in pharma, biotech, and agriculture technology can build upon. It fosters collaboration and accelerates discovery in critical areas like drug development and new biomaterials.
Makes sense. Then there was item 14, Claude for finance. Anthropic seems to be making a very targeted play there.
Very targeted. It's not just a general chatbot dropped into finance. It focuses specifically on the analyst workflow. They're offering a native Excel add-in, which is where analysts live, right? And specialized agent skills designed for common finance tasks. Think calculating discounted cash flows. DCFs, or weighted average cost of capital, WACC, putting together diligence packs.
Stuff that usually takes analysts a lot of time.
Exactly. And crucially, it's built with traceability and governance in mind, so institutions can actually rely on it within regulated environments. It's about workflow integration and reliability, not just chat.
Okay. And Microsoft Discovery, item 15, that seemed to bridge the digital and physical worlds in science.
Yeah, that was fascinating. It combines AI agent teams, a knowledge graph connecting scientific information, and access to HPC high-performance computing resources, all aimed at lab work.
And they had a concrete example.
They did. They reported moving internally from just digital discovery of potential materials to actually synthesizing a physical prototype of a new coolant material in just 4 months. That's a really compelling proof point that these AI-driven agent loops can dramatically shorten physical R&D cycles.
From computer simulation to actual stuff in a lab, much faster. Wow. Finally, item 16, AI blood testing from Perion Biosystems.
Right. The goal here is speed and efficiency in diagnostics. Instead of doctors ordering a whole cascade of different lab tests one after another, Perion aims to use one intelligent blood panel.
One test does it all.
Well, it reads hundreds of different biomarkers simultaneously. Then AI analyzes that complex data to provide a single, unified report much faster. The hope is this speeds up triage, especially in critical situations like emergency departments. It's blending modern measurement techniques like proteomics with smart statistical learning. Okay, last theme. We should probably wrap up by looking at the bigger picture. The financial validation, the market signals, the structural economic stuff that underpins all this growth.
Right, the money in the macro view. Item 20 was hard to miss. NVIDIA hitting $5 trillion in market value.
Yeah, a huge symbolic number. But more than the number itself, it shows how the market now views NVIDIA not just as a chip seller, but as a fundamental backbone provider for this entire new industry.
So like the railroads or utilities of the AI age.
Kind of. And the key thing analysts are watching now isn't just how many GPUs they sell, it's the demand for the surrounding ecosystem. The high-speed networking, the advanced memory, the crucial software layers. That's what indicates the true breadth and depth of AI adoption across the economy.
And this isn't just market hype, right? Item 19, Fed Chair Powell specifically addressed AI growth.
He did, and his comments were really significant. He explicitly called the growth in AI real and drew a clear distinction from, say, the dot-com bubble.
How did he make that distinction?
He pointed out that the leading AI companies actually have substantial earnings. The massive investments being made are seen as durable, productive capital formation, building real capacity, not just speculation on future hopes like we saw in the late 90s. That's a strong signal from the highest levels of economic policy.
Okay, so official validation of the investment thesis. We also saw item 17, the Amazon layoffs, which were framed in an interesting way.
Right, Amazon cut about 14,000 corporate roles. But CEO Andy Jassy was very clear in his messaging. He framed it as a move to flatten organizational layers, remove bureaucracy, and restore speed and accountability.
So, not directly about AI replacing those jobs right now?
He explicitly said it was not a near-term AI automation play. Instead, he positioned it as necessary structural hygiene, cleaning up the organization to make it leaner and faster, which in turn would better support the future large-scale AI investments they know they need to make to stay competitive. It's about preparing the ground. Hashtag tag tag outro.
So let's try to wrap this all up. Looking across all 24 of these updates, I mean, the pattern seems incredibly clear. AI is professionalizing, and it's doing it at, frankly, breakneck speed.
Absolutely. We're shifting from that initial frontier research phase much more firmly into high-volume industrial-scale application. It's all supported by just enormous capital investment and, as we saw, increasingly sophisticated, tighter governance systems.
Yeah, the guardrails are getting built alongside the rocket ship.
Right. And maybe the most compelling thread, the really powerful takeaway for me, is the emergence of what you could call the truly self-improving system.
How do you mean?
Well, think about it. We saw models that might be able to introspect on their own states, like with Anthropic's work. We saw agents that can proactively find and patch their own code, like Aardvark. And we saw research methods like multi-agent evolve that let systems refine their own reasoning capabilities without needing external right answers.
Ah, so the systems themselves are starting to learn how to learn better and fix themselves.
Exactly. They're becoming structurally more self-aware and autonomous in key ways.
Okay, that definitely feels like a profound shift. Which brings us, I guess, to our final provocative thought for you, the listener, to mull over.
Go for it.
If these new development tools, things like Vibe coding and Cursor 2.0, make coding and iteration practically instantaneous, and if agents, as we discussed, can start patching their own security flaws and maybe even optimizing their own performance, how quickly does the speed of technological development, product creation, industrial discovery, how quickly does that speed start to radically outpace our human systems of governance and our regulatory cycles?
That's the big question, isn't it?
Something to think about. We really hope this deep dive helped you cut through the sheer volume of news this